In this video, we will see Enterprise Service Bus in detail. Let's discuss the points. What is an Enterprise Service Bus? Core principles of an Enterprise Service Bus. What is the need of an ESB? Point-to-point integration versus ESB integration and VETRO pattern. What is the Enterprise Service Bus? ESB stands for an Enterprise Service Bus, which is basically a middleware tool for integrating various applications together over a bus-like structure. With the help of ESB architecture, we can connect different applications through a communication bus and enable them to communicate without depending on each other. ESB implementation can be done with the help of bus and adapter. The concept of bus can be achieved through a messaging server like Java messaging services is used to decouple different applications from one another. The data or message passing from one application to another through the bus is in a canonical format. The concept of adapter is responsible for communicating with backend application and transforming data from application format to bus format. Is used between application and bus. Adapter can perform activities like security, monitoring, error handling, and message routing management. ESB offers a centralized point of control for managing connections, message routing, data transformation, and orchestration. It makes it effortless to integrate dissimilar systems and applications. They support multiple messaging protocols and formats such as SOAP, REST, XML, and JSON, providing a seamless experience to connect different services and applications. Now let's see an example of an ESB. Banking sector is one of the most common examples of ESB implementation. Banks frequently have different systems that require communication among them for various scenarios. Let's consider a scenario where a customer applies for a loan through a bank's website. It requires communication between four systems: bank's website, CRM application, loan processing system, and payment system. First, customer fills out a loan application form on the bank's website and ESB receives this information. The ESB forwards this information to the loan processing system, which evaluates the application and makes a decision. If the loan has been approved, the loan processing system sends a message back to ESB, which then forwards this message to the payment system to disburse the loan amount. ESB also sends a message to CRM system to update the customer's record with the details of the new loan. Finally, ESB sends a message back to the bank's website to inform the customer that their loan has been approved and the funds has been disbursed. In this scenario, ESB functions as the central hub for communication among different systems, handling message routing, data transformation, and orchestration. It ensures that all the systems are loosely coupled, meaning that changes to one system do not necessarily require changes to other systems. Now let's see what are the core principles of an ESB. Let's discuss core principles of an ESB. While designing and implementing an enterprise service bus, there are few key principles need to keep in mind. ESBs prioritize loose coupling between applications and services, allowing changes to be made without disrupting other parts of the system. Service-oriented architecture. By treating applications and services as independent modular components that can be reused across the system. Message-based communication. It enables asynchronous communication between the applications. Data transformation. It allows different formats of data to be converted for compatibility. Finally, ESB prioritizes security and reliability. It offers encryption, authentication, and message validation for secure data transmission. These principles make ESB a flexible, scalable, and reliable solution for enterprise application integration. Now let's see what is the need of an ESB. Here are some guidelines on when to use an ESB. If you want to integrate two or more applications, to integrate different systems that are developed on different platforms and use different protocols and different data formats. If organization want to add or remove any application in the future. If applications using multiple protocols. Message routing. If messages need to send asynchronously. Security. To ensure that data is transmitted securely and reliably. Now let's see what is the difference between point-to-point integration versus ESB integration. Point-to-point integration is achieved by establishing direct connections between each application, which means that multiple connections are needed for different applications to communicate with each other. This approach requires custom code for each connection, which can be expensive and time-consuming to maintain. As the number of applications and systems increases, the number of connections also increases exponentially. Moreover, the point-to-point integration is tightly coupled, which means that a change in one application can have an impact on another directly connected applications. ESB integration utilizes a central messaging system called ESB to connect various applications and systems. ESB is responsible for routing messages between applications and can use standard messaging protocols like SOAP or REST. ESBs can also perform message transformation and data mapping, ensuring that the data can be converted from one format to another as it moves between applications and systems. Centralized monitoring and management of message traffic make troubleshooting issues easier, delivering messages reliably and promoting loose coupling between different applications and systems. Overall, ESB integration provides a more scalable, flexible, and maintainable approach to integrate disparate systems and applications than point-to-point integration. It promotes loose coupling, message transformation, and centralized management and monitoring to ensure that different applications and systems work together seamlessly. Now let's see the functionality of an ESB called VETRO pattern. VETRO pattern. VETRO pattern, it's an acronym for validate, extract, transform, route, and operate. Each component plays a crucial role in efficiently processing microservice requests. Let's look at each component in detail. Validate. This component ensures that all the incoming requests comply with the expected format and required business rules. invalid request can be rejected promptly. Extract. This component extracts all the necessary data from the request, including metadata, headers, and payload. Extracted data is then forwarded to the next component for further processing. Transform. It converts the data to necessary format for downstream microservices to handle. This could involve schema conversion, applying business rules, or performing complex calculations. Routing. This component routes transformed data to the appropriate downstream microservice based on predefined routing rules. Routing rule depends on the factors such as request type, destination microservice, and data content. Operate. This component performs necessary operations on data such as logging, caching, or auditing. After the operations are completed, the response is sent back to the original requester. By adopting the VETRO pattern for microservices-based applications, developers can have numerous benefits, including code reusability, modular and scalable development, and independent component development. This way, each component can be replaced or updated without adversely affecting other components. Thanks for watching this video. In the next video, we will see Mule ESB in detail.